All right, so let's review the warm up. The warm up was we're talking about the measure of central angles, and can anybody give me the answer to finding the angle of BE? I'll change that.
No, it's the measure of BE.
The measure of BE. I'm sorry, which is the arc. Should be the arc. So
Isn't
Yep.
that 180?
say it again.
180.
180 is correct. And how do we know this is 180?
Because it's half of the circle.
It's half a circle. If you look at it, the first thing that I like to do when I see these type of problems is I figure out if we have a diameter, and we know that the diameter is just a chord that splits the circle in half, right?
Yes.
And so if you take both halves of the diameter, the arcs would equal to 180. So B is correct, 180. 1 is correct for 180. Did everybody understand how we got that answer?
Yes.
All right, so let me get someone else to give me the answer to number 2. What is AE? AE. So now, arc AE, what you have to do is, of course, go from A and then go into the direction of E. Can anybody tell me what the answer is and how you got it?
It's 148.
Say it again?
It's 148.
148. How did you get it?
Because I take 180 subtract 32.
All right, so you actually use the same formula or the same method that we use for number 1, and we found that this is a semicircle, and from B to E is a semicircle. So from A to E, what you did was you took the whole semicircle and just subtracted from 32 to get 148. That's correct. All right, so let's go on to number 3. Now this one, it says find the measure of the arc AEB. I keep saying angle, but it's the arc of AEB, and we'll talk about it in just a minute too. So AEB, is that, first of all, is that a minor arc? Is that a semicircle or a major arc? Yes, sir. Is it a semicircle? All right, let's look at it again. So we're gonna measure from A to B, from A to E, I'm sorry. Is that, no, I'm sorry, from
Yeah.
AE to B. So this is A, so we're going in this direction, this is E, and then we're going in this direction, and this is B. And the only segment, what's the only segment of the circle that's not missing? That's not into that, that's missing in that that arc?
AB.
AB, right? And that's almost a what?
Full circle.
It's almost a full circle, right? So we know that, and I should have said this in the beginning. So we know that from E to B is the actual diameter. So either side of E to B is a what? Anybody?
Major.
Not a major circle, not a major arc, but what is it?
Semi.
It's a half a circle, right? So if we split this circle in half here, each side of the circle is what?
180.
180, which is a semicircle. I heard that, Kyle. So if it's a semicircle, we know that minor arcs are anything that's less than 180, correct?
Yeah.
So anything that's more than 180 is a major arc. So from A, E to B is what type of arc? Major, correct? And it's gonna be more than 180. So now, if we're gonna figure out the measurement of AEB, what should we do? Based on what's given, how would we figure out the measurement of arc AEB? Anybody?
Add all of the arcs.
You could, however, we got some missing arcs. Those two
I
arcs
got
are
it.
missing.
Minus, I think, because it's an entire circle, so take the 360 and then subtract 32.
Correct. Who said that? That was you said it, and Mr. Tubbs? That's right. So the formula that would get you that, because it's almost a circle, we know that the only thing that's missing from the circle is the arc A to B, which it has an angle of 32. Now, how do we know that the arc is equal to 32? No, it gave you the angle. And that's gonna be a point that you need to remember. We talked about this, on yesterday. So all central angles and arcs are equal. All right? Remember that, because what we're about to go over next is gonna tell you something a little bit different about different angles inside of a circle, okay? All right, so that's correct. When you subtract 180 from 32, what answer did you get? Did anybody say it?
No, wait.
I'm sorry, my bad. From 360, not 180. I said 180 from 360.
328.
328, okay. All right, so now let's look at this arc, angle AED. Is it a major arc or is it a minor arc from A, E, and D?
It's major.
It is a major?
Let's check it.
All right.
Let me trace it.
Wait, no.
I'm gonna trace it right now.
So let him, we're gonna have an outline traced over A, D, and E.
It's from A to what?
A, E, and D.
A, B, D, so it's in red.
All right, so now, if this line was the actual diameter, we had a line from here to here, creating that diameter, would that be a major, a semicircle, or a minor circle?
Semi.
A minor arc.
Semi.
That would be a semi where the ruler is. So from A, E to D would be what type of arc?
Minor.
So it'd be less than what?
180.
180. So how would we figure out the total amount for A, E, and D? And we already have A and E. So how would we get, if A and E arc is 148, A, E, and D would be what? And how would you get it?
You add 148 to 24.
Yeah, 148 to 24, and what do you get?
174.
174, or is it 172?
It was 172.
172. All right. And the last one, number 5, we're gonna find arc BC. So we already said that B and E, right, is divides the circle in half. So you're looking at this half of the circle. How would you figure out BC, the missing arc? Yes, sir.
Would you subtract 86 and 24?
Say it again.
Would you subtract 86 and 24
From
180?
correct. So if you subtract 86 and 24 from 180, put it up on the board. Anybody know what that angle should be equal to?
70.
That's correct. Because 86 and 24 is 110, and 110 from 180 is 7. All right. Make sure you have this written down, and make sure you have your notes written down for central angles, because we're about to go over a different type of angle inside of a circle. Which leads me to our learning target for today. So our learning target for today is that we will learn about the relationship amongst inscribed and central angles. And in how you know you are successful, it says, I know that I am successful when I can calculate the arc measures or angle measures of inscribed angles. All right? So, let's talk about what we have here. An inscribed angle is a chord where you have two chords that meet at the circumference point on a circle from two different points of the circle. So you have a chord, this is a chord that goes from this point of the circle to this point of the circle, and then it creates a vertices, or it meets at a point inscribed in the circle from one point on the circumference, meeting at the chord at the other circumference, okay? Let me give you a better definition.
And while he's doing that, when you look at the shape, like what shape will like give you, like what does it look like inside? Huh? Looks kind of like a cone. If you look at it, just like a flattened cone or whatever. So when you think about it, but what's the difference? Because the central angle looks like a cone too, but what's the difference between this angle and the central angle?
It's in the center of the circle.
What's in the center of the circle?
The forgot.
Which angle comes from the center of the circle?
What's the name of the angle? What type of angle is it? So this is an inscribed, and the other one is a. Say it again. Somebody said it. No, it's not outside. It's gonna be
What was the other angle that we talked about yesterday?
in the point of the center. Those were called what type of angles?
I wasn't here yesterday.
If we looked at the green angle, and I said that this point is the center, what type of angles did we work on yesterday?
Do you have the worksheets with you?
What's another word for center? The center of something that starts with the letter C.
Central.
Central.
Right.
You
So
wasn't even here yesterday.
yeah.
So this would be called what type of
Just
angle?
make me look bad.
Central angle. Right. Right. So it's a central angle. So let's give me give you the better definition that you can write down for the inscribed angle. It's two chords that intersect and have a vertex on the circle at another point. All right, and the angle creates an arc. All right. So the thing that we know about central angles is that the degree of the angle and the arc has the same measurement. All right. But for the inscribed angle, the arc is 2 times the measurement of the center. So if you were looking at this angle is angle what? Has what type of degree? 48. So in order to find the arc of this angle, what would, now if it's 2 times, what would that measure of that arc be? Calculators are allowed. 96. So the measure of the arc would be 96. Or the measure of x would be 96.
Go through it again, Coach.
Sure.
Just for how we got it.
Okay, all right, so you have,
The angle. The angle.
so you have the angle here, 48 degrees, right? And an inscribed angle is 2 times, the arc of an inscribed angle is 2 times the measure in degrees of the angle,
You got said it was what, 96?
96. So I always like to ask what if questions on this one, since we know this part, we know that the measure of the arc is equal to 2 times the measure of the angle. What if the arc was given to you and the angle was x? How would you figure that out? What if?
You do
let's just say we said this arc was 48. Let's move the 48 down here. What would the measurement of the angle be?
24.
Say again?
24.
Couldn't hear you. Say it one more time.
24.
24. How did you get it? What did you do?
Because you divide the 48 by 2.
Correct. You just divide the 48 by 2 to get that particular answer. And we're gonna see a model of it now. And we're gonna move X up, then do it. So now understanding this, and we're gonna get a model we're gonna show. So now you said the measurement of angle, the angle would be now 24 because it's 1/2 the arc, correct?
Yes.
All right. Very good. So now if you understand this portion of what we just taught, you should be able to complete the exercise that's gonna be given to you in Delta Math. And it's parts of a circle and inscribed angle. Do anybody remember the parts of the circle? Y'all remember when we went over those? Parts of the circle? We talked about what a radius was, what a diameter was, what a chord is, what a tangent, point of tangency, and a secant. Okay, so that's gonna be your next assignment in Delta Math. And does anybody have any questions about what we are going over, what we've gone over? All right, so let's go over one problem in Delta Math. All right, so let's look at this. It says circle P. So we always identify the circle by the center point, right? So it has circle P. In circle P, with the measurement of measure of angle NPQ is 82 degrees. Find the angle measure of a minor arc in Q. So what would be NQ? Can anybody give me that answer?
Wouldn't it be 82?
It would be 82.
Why?
Because you said the arc is equal to the center.
For what type of angle?
Minor arc.
Not a minor arc. Starts with the letter C.
Central angle, right. So in central angles only, the measure of the angle in the arc will be the same. Inscribed angles, the measure of the arc is 2 times the angle. Or if you get the arc, the measure of the angle will be 1/2 the arc. All right, let's look at one more problem. All right, what type of angle is this?
Uh-oh, sorry.
There you go. Hmm? Is this a central angle or an inscribed angle? Inscribed? Okay. Thanks for that, Mr. Tuggle. In circle P, with the measure of the minor arc in Q equaling 50, find the measure of angle in RQ. What would the angle of NRQ be? NRQ. Say it again, somebody, heard somebody say it. 25, was you David? All right, 25.
Why?
Because it's not a central angle, so we have to divide by the
Do you do you just divide it by 2 because it's not a central angle, or?
So what's the rule?
What if it's not, so what type of angle is this? I thought it was letter I. Inscribed, alright? So, we know that we could divide it by 2, but because it's an inscribed, right? But there's some situations where that angle is not going to be at the center, or it's not gonna be inscribed, and we just can't assume that it's gonna be half if it's not central. So, say if you got a circle like this, but the angle comes way out here, something like that. Could we, and this was 50 here, could we say that angle is 25? No, we couldn't say that angle is 25 because that vertex is not on the what? It's not on the circle.
Circumference of the circle.
Yeah, on the circumference of the circle. So make sure that we use the terms inscribed and things of that nature. I'm sorry, Coach.
No, you're good. So that's what I was about to bring the point to. So this formula only works for inscribed angles. And the other formula where the angles are equal to the arc is only for central angles. So remember, we're dealing with central and inscribed, and that's what your delta math is gonna be gonna deal with. So remember, so just remember that when you have inscribed and central circles, you have to identify those before you can use these formulas.
So,
Yes, sir.
so since it's the second circle like that, can you tell if it's an inscribed or central?
Right here?
Yes.
Yeah. An inscribed circle is always gonna touch the point on the circumference of the circle.
So if
So this central angle is not touching the point.
That's not essential.
Could you take the lead for
Okay.
Yeah, guys. I already stepped up. You can't tell that that's a central angle because we don't know that if it comes from the center. And the only way you know it comes from the center, they will have a point for the center. So let me put this down. So if that yellow dot right there, it was not yellow to you guys. If it's not